So we want to find the max height of the biker, and we're going to do this using energy. So from the video, we know that the biker weighs, and his bike combined weigh 88.45 kilograms, and he leaves the ground with a velocity of 7.34 meters per second at an angle of 50.334 degrees. So what we want to do if we're going to be using energy for this is first find the vertical component of his velocity. How are we going to do this? So we can make a triangle. That since velocity is a vector, it's going to have vertical and horizontal components. So we know that this component of the velocity is 7.34 meters per second. And we also know that the angle here is 50.334 degrees. From this, we can say that the sine of this angle 50.334 degrees is equal to this vertical component of velocity over this component that we already know, the hypotenuse, of 7.34 meters per second, to give us our vertical component of velocity, which is 5.649 meters per second. From these two equations, we know that the values that we do know are his mass, velocity, and the gravitational acceleration. We're trying to calculate this height. So we can say that his kinetic energy is equal to 1/2 times his mass of 88.45 kilograms times his velocity squared, which is 5.649, his vertical velocity, 0.649 meters per second squared, which comes out to, in the end, 412.07 joules. Now we know that his kinetic energy is 1,412.07 joules, and that his kinetic energy is going to equal his potential energy. We can say that 1,412.07 joules is also equal to his mass times the gravitational acceleration times the height that he gets to. Again, we already know his mass and gravity. And so to calculate the height, we just divide. Gives us 1.6 meters. So now we want to find the horizontal distance that the biker covered. So in this, instead of energy, we're going to be using kinematics. And we know that for distance, in kinematics, delta x is equal to the velocity in the x direction times time. We also know that from the video that the time that the biker spent in the air was 0.90 seconds. We need to find this horizontal component of the velocity. Again, like before, we want to use a triangle. And again, since we know that velocity is a vector, we know that it has both horizontal and vertical components. It's pulling from the first half, and from this triangle, we can say that the cosine of the angle 50.334 degrees is equal to the horizontal component of velocity over the hypotenuse right here, which is of 7.334 2.4 meters per second, which comes out to 4.685 meters per second. So now that we have the horizontal component of the velocity, which is 4.685 meters per second, and the time, 0.9 seconds, which are the two variables we need to find the displacement in the x direction, seconds cancel out, we just need meters, and it's going to come out to 4.22 meters in the x direction.